In the previous video, we have seen why you need to learn C for embedded systems. So that is the question that we addressed in the previous video or the previous tutorial. In this tutorial, we're going to see how do we create C programs. So what is the process of creating a C program? So we'll see this part in this video. So there are three fundamental stages or processes in creating or in creation of any C program. So that is editing, compiling, and executing. So first, let's look at editing. Editing is the process of creating and modifying C code. C code is basically the name given to the program instructions that you write. So you'll have a C source code file that we create or modify it. That is we basically call as editing. So editing the C code, the C program. Now you can use any integrated development environment, also called as IDEs, such as Eclipse or Visual Studio Code for writing, managing, developing, and testing your programs. So this brings a lot of flexibility for your code development. Also, you can use general purpose text editor to create your source files, but editor must store the code as plain text without any extra formatting data embedded in it. So for example, you can use editors like Vim if you're on Linux. Alternately, you might prefer to use GNU Emac editor. It's one of the editors that's available in Linux, but you can see the same editor which is ported for Windows as well. You can use that. With Microsoft Windows, you could use one of the freeware and shareware programming editors. So normally in Windows, you have something like Notepad++ or simply Notepad. You can use such tools. So these will often provide help in ensuring your code is correct with syntax highlighting and auto indenting. So there is also a version of Emac for Microsoft Windows. So as I said before, the VI and VM editors from Unix environment are available for Windows too. So as I said, these VI or Vim are also available on Windows. You can make use of it. Also, you can use the Notepad++. Okay, so that's basically about the text editor. The thing is that you cannot use, for example, Microsoft Word. It's also a text editor, but it does not edit text as it is. It actually does some formatting. You cannot edit the C code with tools like Microsoft Word. The next thing is compiling. So compiling is a stage where your source code gets converted to a machine code. So let's see what happens during compilation. Compiling C code involves several stages, each responsible for specific aspects of the translation process from human readable source code to machine executable code. So anything that you write in the text is a human readable one, and that gets converted to machine executable code. So here are the typical stages of compiling C code. So the first stage is pre-processing. In this stage, the processor processes the code. Uh, in this stage, preprocessor processes the source code. The preprocessor directives, which begins with hash symbols. So anything that you see like this, hash include or hash define. So these are basically preprocessors. Also, you'll have something called hash hash if def, if not defined, and if else, and all this you basically comes under preprocessor directives. Well, so this everything starts with hash is called as a preprocessor directive. And a common Pre-processing tasks including header files, as I said, hash include, the macro expansion, like anything that you define is a macro expansion, and conditional compilation, like if def, if not def, end if, all such things. The output of this stage is often referred to as a pre-processed code. So once the pre-processing is done, you can actually see the code of that using minus e compiler option. So you can use minus e compiler option to get the code, get the output of the pre-processed output of the preprocessor. So we will see that how to do that. Next is the actual compilation. The pre-processed code is then passed to the compiler. The compiler translates the C code into assembly code or an intermediate representation. This stage involves lexical analysis, syntax analysis, semantic analysis, and optimization. So we will see more about this in the next episode. So the lexical analysis, syntax analysis, and semantic analysis are basically like checking the grammar, checking the have we used the keywords of the, let's say, C C language has certain keywords. Are we using this as a variables? So such things, grammar, syntax, all of this will is kind of checked in this stages. After that, the output is typically an object file, often with a data or obj extension, which contains machine code in a relocatable format. So we'll see compilation stage, like we will see the compilation in greater detail in future, as I said. So the stages like lexical analysis, syntax analysis, semantic analysis, these are quite extensive, and we can actually of course, we need to learn more about this in order to really understand how C is compiled, so how a compiler is actually working. So this part is very important. Okay, so the compilation stage gives us data files, so the object files. Next stage of the processing your C code is assembly. The object file generated in the compilation stage contains machine code in a format that is specific to the target architecture. So as the target architecture means, here you can have x86, 64, or you can have like ARM architecture, you can have PowerPC architecture. These are all the different microcontroller or microprocessor architectures, right? So as we said, in the previous video, so we said like once you write a C code, you can run in multiple mm, platforms, architectures by compiling the code for that particular architecture. So that's what is called a portability of your code. Well, so in the assembly, your specific your machine code, sorry, during the compilation, your code is the machine code is in a format that is specific to the target architecture. The assembly stage translates this machine code into actual machine code instructions for the target platform. The output is an assembly file or an executable file, depending on whether the code is intended to be part of a library or a standalone program. So for example, if you want it to be intended, if you want your code to be part of library, assembly actually generates something like .so or shared object, or in this is basically in Linux, and in Windows you'll have like DLLs or .a files. These are the object files. The DLL is dynamic link library, which we will see uh, next. So this is one aspect of it. After assembly, other is normally you get the exe file .exe file, which is an executable on Windows, and normally on Linux you have your executable, the file name itself, and that you can just execute with dot slash and your file name. That's how it is. So we'll see that during the execution stage. Well, so output of the assembly is your either object file, the dot shared objects, the library files, or an exe. And the next stage is linking. In practice, a program of any significant size will consist of several source code files from which compiler generates object files that needs to be linked. So in the assembly stage, you have the DLLs or the object files. These files needs to be linked. This happens in the linking stage. By breaking it up into a number of smaller source files that each provide a coherent part of what the complete program does, you can make the development of a program a lot easier. So this is actually where developing the if, code in like modular approach, modular development. So this means that let's say you have a very large project, and this large project is your this basically split into several files, and these files are, I would say, modules. In even within each modules, you can have several C source files, and for each module, you can create a library. So these libraries, let's say like lib1, lib2, and all such things, and this all of this can be linked to a bigger project. This linking stage. Okay, after this linking, you will have the actual executable generated. Okay, so with this modular approach, you are developing a code which can be plugged into other programs as well, but also it makes programming a lot easier in terms of managing the source code as well as let's say one person cannot develop all the modules, right? Like software development is basically a community activity, I would say. A lot of people are involved, and that's why people say you need, it's not just your technical skills. You should have soft skills like how do you communicate with other team members. So all of this come into picture, which we will touch upon a little bit as we go in this course of tutorials. Well, so that's for the next. That's up for another day. Okay, back to the topic. The source files can be compiled separately, which makes eliminating simple typographical errors a bit easier. So as I said, separately we can develop the modules. And after developing these modules, we can link them together. So the linking basically, what linking does is it resolves symbols like variables, functions, and addresses, ensuring that the references between different parts of code are correctly linked. The output is an executable file with a binary format specific to the target platform. For example, ELF on Linux, P on Windows, and things like that. So this basically creates an executable as after linking. So the linking process involves two main types. Yes, there are two types of linking. So one is static linking and dynamic linking. So in static linking, all necessary code is combined into a single executable file. Okay, so in dynamic linking, some code may be left in separate dynamic link libraries, as I said before, like DLLs or shared libraries. So SO, as I said, shared object in Linux, that's what it's called, and linking occurs at runtime. So normally the static linking libraries are in the extension .a. DLLs are basically in .dll or .so. So when you compile a code with static linking, your code size becomes more because all necessary code is combined into a single executable file. But if you do a DLL, So your final application size may not be as big as stat linking, but you will have to have the DLLs along with your program. You should have DLLs available for you to run this particular program that you have written. So that is the understanding. I hope it's a little bit clear. So we'll touch upon all this as we go through. Okay, the final stage of your C program is basically executing whatever you have written. Well, the execution stage is where you run your program, having compiled all the previous process successfully. Let's say, unfortunately, if this stage can be generate a wide variety of error conditions that include programming the wrong output, just sitting there and doing nothing, or perhaps crashing your computer for good measure. So in all cases, it's actually we have to go back to the source code, the first stage of editing, then get things corrected. So that's how it is. So here the what happens is, let's say if you want to put it to like an embedded system. So for example, you want to you have to blink an LED using a port one. You might have done with port two, something like that, or you just wrote everything in a while loop, and then there is something which is getting stuck, which like you can have something like something which is stuck, and then your watchdog can reset. So there are a lot of issues even after you successfully compile and run the code. So while running, you might end up having runtime issues. So having a good design is something which is very important. We will work on that. So now for the good news, okay, in successful case, the stage where the program works, you get to see your computer doing exactly what you want to do. So assuming that you have no errors during compilation, linking, and even runtime, your code works perfectly. So that's the ideal case. So in Unix and Linux, you can just enter the name of the file that has been compiled and linked to execute the program. So for example, you have something like hello, then you can just hello is your output or executable. You can just dot hello. So this is, let's say if this is your terminal. The terminal you execute the hello and then it'll print out whatever the output that you're expecting. But in most IDEs, you'll find an appropriate menu command that allows you to run or execute your compiled program. So for example, you have Eclipse or any IDE for that, I mean, for that matter, you'll have some menu options where you just set it and then you'll have this run button and the build and things like that, that you can set it. With that, you'll be able to run the program. But I normally prefer working on the command line. Okay. So in Windows, you run .exe file. Of course, you can run like /exe, or you can double click on the exe and you will be able to see uh, your program getting executed. So that's on Windows. The process of editing, compiling, and linking, executing are essentially the same for developing program in any environment and with any compiled language. So the steps that I have mentioned here actually holds good for C, C++, Java, or any other compiled time languages. Okay, so any compiled time languages. So for example, interpreted language like Python, this doesn't hold good for Python because as and when you write the code and hit the enter or hit the uh, how I would say if you open the Python terminal and then if you open Python as an interpreter with an interpreter, every time you put a command, it prints. So of course, all these things happen in the background. So as a programmer, you don't see it. So figure below emphasizes how you would typically pass through process as you create your own C programs. So if you see, the first step is editing. Here we create, modify, program the source code. And that source code, the output of this is basically your .c file, source file. It's called anything .c. Your compiler accepts only .c file, .c format. It doesn't accept any other format. Next, you have a compilation stage where it generates machine instructions that basically gives us the object file. Let's say in compilation you have any errors, you go back to your drawing board or editing. Then, assuming that you have no errors, then it comes to linking stage. In link, it links the libraries and it produces an executable called exe file. If there is errors, you go back to editing. Then if there is no errors, you execute the program and your program runs successfully. Oh, I would not say successfully. If you run programs and if there is an error, you go back to editing. Otherwise, your program success. Your program is executed successfully. So this is how typically you develop the C code. So now let's see this in practical. Let's practice this. Okay. So if we create, let's create our first program. So traditionally, Hello World is the first program in learning any language. So we will stick to the same. Of course, you can do instead of Hello World, you can put anything, but let's just follow the norms. Okay. The first stage is edit. So we can use any editor. So run, my favorite is VS Code. I'm going to use VS Code and then put this code into the .c file. Okay, so let me open this VS Code, Visual Studio Code. So in the interest of time, I've already uh, typed it here. So the first line is a comment. The next is we do an include stdio.h. This basically is to include the standard library, the standard library header. So int main void, then open the brace, the printf hello world, return 0, and then close the bracket. So well, I'll explain you all this in the next episode. We will dissect this, what's happening in all of this. Just trust the process. You will learn. So for now, we'll just try to run this and see what happens. This is like putting the code is basically editing, and you save it. We saved using hello with the name hello.c, and the terminal, I just opened the terminal. So I will just go to src here. Okay, then ls, I have hello.c here. Okay, so basically what we've done is we have edited the code and then saved the program as hello.c. This extension is the common convention when you write C programs. Identifies the content of the file as C code. So your compiler basically sees this .c, that understand that it is a C code. Okay, so for C++ it is .cpp, and of course different languages have different extensions. Okay, now compile stage. So in order to compile on Linux shell, okay, first thing is that you need to get a compiler, right? So on Linux you can just install GCC by, let's say if you're using Ubuntu, you can use like apt get install GCC. So it'll install the latest version of the GCC. But on Windows, you can use MintW, which is GCC builds to work with Windows. So you can get it from this link. Uh, I will put it in the uh, description of this video, and you can install like how you install the normal Windows applications. So I'll have done that. Now, in order to run, sorry, in order to compile, you just do a gcc hello.c. So let's do that. So gcc hello.c. Okay, so you can see that it created a.exe file. So here I have not mentioned anything. It just created a.exe. So a.exe is the default file name that this compiler gives. That's okay. And okay. And if I want to see, okay, this we will see later. And if you want to execute, what we will do is we will just, so dash backward slash a.exe, boom, you have hello world.c printed. So it did some magic. We will see what it is in the future in the next episode. But for now, you just understand how a C code works. For example, what you've done is you missed this. Okay, let's let's try to compile it. GCC, you see that here is an error. Expected a semicolon before written. So that's an error. So what we do? Okay, the compilation failed. So we go back to the editor and then we fix this error and then do a compilation, and it worked. So that's how. So whenever you have an error, you go back to the C code and then fix it. Okay. So now we have printed hello world, but let's say I wanted to see the pre-processed file. As I said, pre-processed file is basically .i file. Okay, this is the format. This is the extension. So the and I said it like I need to use minus e option, or I need to give minus c compiler option to produce the pre-processed file. So let's go here, gcc minus e, and the file name is hello.c, and the output I want to produce is hello.i file. Okay, you see it has the hello.i file. Okay, and if you see here, it's a very big file, right? So there is a lot of things that's happening in the background. But if you see, your score is at the end. This allow.c, the line number 4, 5, 4 to 8 are basically at the end. So what is happening is this stdio.h include is actually including all of this code before till the code number 436. Everything is included as a pre-processing stage. Okay, and say for example, what I'll do is I'll just define hash define, say something like pi. Okay, pi is basically 3.14, hopefully. Yeah, that's the pi value. Okay, there is so much decimal places that you can go on, but 3.14 is mathematical, let's say, precision to two decimal points. Okay, so what I'll do is I'll just create one more variable here, int area. Okay, and int radius. Okay, so the radius, I will just use radius as radius equal to 10. Okay, so what I'll do is I'll just print this printf printf with the quotation area of circle is, what I'll do is, uh, well, so we'll get into this later. Percentage d, the is basically here we're saying that I'm going to print a decimal value here. Okay, oh sorry, it's a float. I would say a float. I'm going to print a float value, and that value is, okay, here before that we just calculate the area. Okay, area is, I would say, not an int, it's a float. Okay, is pi r square, right? Pi is this pi. Okay, I just copy paste here. R is radius into radius. Radius into radius. So I put a semicolon there, and then I print the area here. Right? Hopefully I've not done any mistakes. Then let's say I will just do hello. Okay, this one. Okay. Or I first execute the program and see if my program is correct. A.exe, and it says okay, 314, whatever. Well, so now if I just go and try to see the .i file, the preprocessed one, if I open, you can see that the area, what we have written is pi value here, but it got replaced here. So that's what exactly happened during the preprocessing. Okay, so we have defined, hash define here, and that is what has come here. So that's the preprocessing in a nutshell. Okay, so that's all for this video, where we have seen how do we create a program, compile it, link it, and execute the program. I hope this is helpful. So thanks for watching. Hopefully better than the previous one. Thank you.
Subscribe to the channel for more projects, courses, tutorials, and tools.